Hello. Hi.
Hey, Joseph, you want to introduce yourself?
Yeah. So I'm Joseph Wang. I'm calling in from Hong Kong, where it's like very late right now. So what I'm doing is I'm setting up a small research lab. My background is astrophysicist. I was working in an investment bank for a couple of years. I'm now in cryptocurrency, and my interest in Jupyter is I'm trying to essentially take a lot of the high performance software and HPC technology that's being used in science, and basically trying to merge the worlds of science and finance, and to encourage like technology transfer between particle physicists and quants at banks and hedge funds. So the thing that I'm doing right now is I've been spending the past months trying to go through the Hong Kong bureaucracy to get some funding to work on these technologies, and I've got a grant that's being shuffled through the bureaucracy, and I'm anxious to see what I can do to help the general community.
Awesome. Well, that's pretty exciting. Yeah, I'm sure there'll be lots of ways to help. So we can talk about that too more in depth. Maybe even set up a smaller call to do that, if that would be useful for you and you start having cycles.
Yeah. I mean, I think one of the things that I'd like to do is a lot of the stuff that I've been working. I mean, just to find a lot of the stuff that I'm working on would probably be best discussed offline. So I'm actually trying to get active on some of the chat groups and sort of the offline forums, so that we can actually start going through what can be done. But basically, what I'm actually trying to do with the grant is to make it so that it's as open as possible, so that whatever the need is, I've written the grant in such a way so that whatever the need from the community is, that I can convince the funders that this is what should be done. So that was part of why it took so long. Is I wanted to make it so that I wasn't locked into a particular set of technologies.
Awesome. Well, that would be pretty exciting. And it'd be great to have as much help as we can get here. So, all right, I think next, Tony.
Hi, I'm Tony. I'm a data scientist at Quanti. I'm just trying to keep my finger on the pulse of what y'all are doing.
Sweet, thanks. Zihan?
Oh, hi everyone. I'm Zahan, and I will be a PhD student at the University of Michigan, and my research interest is in HCI, and my future advisor had been in a previous meeting, and so we have built some system or UX design for Jupyter Notebook, and now we're interested in some authorization and access control on Jupyter Lab. So I'm here to see if there's like what's the current situation is like, or if there is anything we can help or like help to develop or design something.
Awesome. And you said you're building a system right now, or you have a system in place at the university?
Yeah, we actually, we've had a plugin built for Jupyter Notebook, which is sort of like a real-time collaboration system. And we have this paper published. It's actually in the last week's meeting note, but it's more of a demo type of things. Yeah. So that research topic was more of like enhancing the communication part while in the real-time collaboration settings. And now we're interested in more like the access control part, and we're looking forward to do it on Jupyter Lab, sort of like this.
That's awesome. And yeah.
Zihan, have you followed any of the work on Jupyter Server on authorization and access controls?
I've just started to reading some notes in the issues and something, and I've noticed that some like use cases like provided by Vidar was like very interesting. It's like basically what we're trying to look for or solve, this stuff like that. But I haven't got into like the implementation level of things.
Okay, yeah, Zach Saylor, he's not here today. There's a separate Jupyter server meeting where some of that work is going on. We can provide you with details.
Yeah, that would be great. Yeah, thank you.
Sweet. And yeah, I had a chance to skim some of that paper and it was really interesting work. So I'd recommend it to anyone else. And thanks for doing that.
Yeah, thanks.
All right, Daniel.
Hi everyone, I am Daniel. I am a software engineer at QuantSight, currently mostly focused on spider development. Yeah, I'm here basically to learn a lot. Yeah, and see if I can be helpful in any way.
Awesome. Thanks. Stephanie?
Hi everyone, I'm currently a software developer in QuantSight, and for a while I wanted to get started in contributing to this project. So I'm really excited to see what can I do here.
Awesome. Thanks, Stephanie, for joining. Nick?
Oh man, the first rule of RTC club is you have to talk. Hi, I'm Nick. I work at Georgia Tech. I write code, been Jupyter core for however long, I don't know. I'm interested just because I've built 2 different real-time collaboration front ends for or back ends and front ends for the Jupyter stack, and I'm interested to see if there's any insights from having been down that painful road that if I can share, but also to see what the goodies are.
Sweet. Thanks, Nick. Yeah, and I was just thinking, so that sort of to go over a little bit more of the format of the meeting, I'm sort of just scribbing this from how Jupyter Lab runs their meetings, but if you have anything you would like to discuss, it's sort of open for anyone to suggest topics. So if you'd like to have a longer discussion during this meeting, feel free to put an item down on the agenda. Yeah, and so we'll kind of just go through those after we do introductions. So I think that's everyone. And yeah, I had a little demo I could start with, and then that could kind of lead into some discussion of architecture, and would love any thoughts there. So yeah, I'm gonna share my screen and try that. So yeah, I was trying to work on just a little proof of concept to demonstrate the idea of having like a node on the server that connects to the Jupyter server and keeps the data model up to date. And this is different than how Jupyter works currently, or Jupyter Lab at least, because it connects directly to the server itself. So what you'll see here is this is a little debugger, and it shows all the tables that we have in our data store, and they start out empty. And here, this is just a little UI. I can see that I have a notebook here. It just has a few cells in it. So I can load this notebook. And then this is just a very rough kind of UI to let us start to look at it if this is working or not. And so this is trying to show you that outline of the notebook, the different cells, etc. And then if we look, for example, how this works is there are all these tables right in the data store. And so they're loaded, or they're filled in by the server who talks to the Jupyter server. So here we can see there's one item in the contents table for this notebook file. And it points to a content ID, and that's in the notebooks table. So if we look in the notebooks table, then we'll see, hey, there's a notebook with a certain ID, and it has a number of cells, each which have IDs. So I can look in the cells table, and I can see each of these cells. You know, they have their metadata and their execution, and so that's in the executions table. So yeah, this is still very preliminary. I don't have most, you know, just sort of like a rough end-to-end kind of example here to illustrate a proposed design, I guess. Yeah, so maybe I'll stop here. I imagine we're all probably at different levels of comfortability with this kind of model. So maybe I'll just open for questions or feedback from others at this point.
So a couple of questions about this. So you have a schema for all the different tables here. This is a Node.js based Supernode server.
Yep.
So, and is it talking to the Jupyter server in any way, or is this a completely separate process for now?
Yeah, it's a separate process, but it's talking to the Jupyter server.
Okay. Fantastic.
Yeah. So the idea, or at least the initial idea here, is that this wouldn't replace any of the existing Jupyter server code or work. It would sort of sit beside it and call out to it to do all the actual execution.
So I've got a quick question. For the demo that you have, is it a standalone Jupyter server, or is it running under Jupyter Hub? So is it already linked in with multi-user?
No, this is just a standard server at the moment. So the multi-user kind of capabilities would have to be built on top of all of this. It's sort of after it's more fully baked, I would imagine.
Okay.
What one question or thing for us to think about is, and actually let me describe for the broader audience here. So these tables and their schema are in the Lumino data store in the Jupyter Lab repo, and we support the following field types in those tables. So we support scalars, maps, lists, and text. And the scalars are just normal types, so numbers, strings, etc., that are not collaborative internally. The algorithmic characteristics of each field differ pretty significantly. The scalars and the maps tend to be much more efficient than the lists and the text because of the ordering of the lists and the texts. And so one question I have here, Saul, is where do those more costly field types show up in the broader schema? And I'm thinking about, are there performance issues that we need to think about here with outside of the traditional notebook text editing type of experience, but for example, with sessions or with contents or the other parts of the API that we've never thought about modeling it with this data store before. And so I'm wondering sort of how you see that.
Yeah, I think there's definitely could be performance issues in a lot of places. I guess the way I've been thinking about it so far is so for things that aren't collaborative or two people wouldn't need to be editing at the same time, and maybe whether that's like even something like, I don't know, if I can find a good example, but like here, like a kernel spec file, right? Like that doesn't really need to be collaborative. You're not going to be both editing that, or for example, like other kind of compound fields where you don't really need individual edits on each, then you can kind of group those as one field. But there's definitely some trade-offs. And I mean, so I've been using, for things that you wouldn't both want to edit character by character, I've just been using string instead of text. So it's just I don't know if that's kind of what you're getting at, or.
Well, and actually, were there other places that you needed to use the collaborative list sort of outside the notebook model?
That's a good question.
So one way of thinking about it is to think about the Lumino part as sort of a an adapter so that Jupyter sees, talks to Lumino, and it has a set of data structures and data fields. And then you could actually use that as a front end to connect to some other database and use that as sort of a translation mechanism. Because if you do that, then what happens in a lot of cases is that you want to do as much processing on the back end as you can. And so the idea would be if you have like a database with 5 million fields, right? You wouldn't actually do the processing in Jupyter. You tell the database, okay, I want to process this stuff. Now that I've processed into a graph, then I use this API to pull that data over so that all the heavy duty stuff is done at the back end, and that gets around scaling problems.
Well, some of them. So that gets around the scaling problems as the number of records grows, but each
but I see what you're saying. Yeah.
Each field in each record still maintains the full history of its changes.
Yeah, I see the issue.
And all of those changes are needed by any process that wants to look at the current state of that field.
Yeah.
So but yeah, absolutely, we would be storing these transactions in some sort of scalable database, whatever that means for the current or the situation.
I think.
Right.
Yeah.
So I have some question about the Supernode implementation. I haven't looked at it too closely, so just for summary, you're currently using, I guess, the Jupyter Lab Services package, but are you using any of the other packages to kind of process the responses from there, or is that just super trivial to react to the server messages?
Yeah, that's a great question. Just before I lost the thread, just on Brian's question, I think I'm mainly just using primitives for everything else besides the notebook, besides maybe folders, the list of things in a folder. But yeah.
Okay, that's fantastic. Yeah.
Cool. Yeah, Vidar, that's a good question. Right now, it's not doing much, so I'm really just calling out the contents API, but I think we will either need to use the Jupyter Lab, or it might make sense to either use the Jupyter Lab or the Interact packages for interacting with the server itself. I was kind of curious how the Interact ones were working, so I pulled those in to try them out. So I'm using those to just get at the contents management.
Can I toss a concept out here? So things that feel like streams to me, I am less and less sure that they belong in the notebook server. And I am coming more around to the concept that anything that kind of quacks like this should probably be a kernel. So have you had any thought towards not doing a custom WebSocket, but instead offering this as an extension on top of the Jupyter kernel messaging protocol, potentially as a COM target? So the advantage I see there is every Jupyter client that implements widgets knows how to speak COM, and you would have access to all the tooling and testing that people have already done in order to support widgets, which are not fun, right? If you're doing a greenfields implementation. And it would also formalize it such that, as a JEP, it would be possible to re-implement if you don't like Node.js, which I have users that don't deploy Node.js things ever. And it would change the locality because, okay, you're in Hub, you fire up the server process, so what? I mean, that's going to go away tomorrow. It's not guaranteed to be running in the same place as where your kernel's actually running, whereas a RTC kernel could be guaranteed to run in the place where you're expecting it to actually be. And also maintaining kernel environments is a better understood problem than notebook server environments. So these are some of the things that I've been wondering about.
I saw your work on the debugger stuff as a custom kernel. But I think I can kind of see where you're coming from, I think, if I'm understanding that right. I hadn't thought about that. I think about it as a different level. Like this is just throwing this out there. Like in a future world where this existed, you wouldn't have support for comms. This would give you support for kernels. So you wouldn't have, this would be more primitive than a Jupyter client app that connects to your kernels, right? So it is replacing that mechanism, if that makes sense. So you'd use this to connect to kernels.
Doesn't.
Yeah.
The kernel's the best thing we got. You know, every time we make up a brand new transport, it is painful to implement something new on top of it. Anyhow, sorry. I don't see it as more primitive. I see it as more complicated.
It's interesting, Nick. We're running into this question. So I'm currently at AWS, and we have SageMaker Studio, which is Jupyter Lab, but we have remote kernels. So the kernels run on other instances. And one of the design and architectural challenges we're having is server extensions that run on the main instance. That instance is very small and has finite compute. And so we have to be very careful about what server extensions can run there. And so we're getting into this space of asking which things are better as a server extension versus which things are better as a kernel. And the properties of kernels that I like, what characteristics do I see that we're looking at? One is variable compute, where you may discover that a process a computation or server, et cetera, needs more compute. Kernels are designed for compute intensive things, and we have all the network architecture to distribute them in a way that makes sense. The other is, honestly, not just variable compute, but is significant compute. To have a process that's sort of adjacent to the Jupyter server that's running a large number of, is CPU and RAM intensive, changes the profile of deploying Jupyter, even in a Jupyter Hub context. And even though from the network protocol perspective, in this case, I'm not sure that comms actually, yeah, I agree, it simplifies certain things, but it may complicate other things. And so I wasn't thinking of this originally that way, Nick. I'm just validating that, yeah, we're running into other things in this class where it's a significant process that maybe like running on the same instance where the Jupyter server is running may cause pain.
Yeah. Also, I don't know if you want to answer anything there, Nick. So maybe go ahead with that first, if you did.
No, I'm good. I mean, just the experience from the aforementioned PR, which was not actually on debugger. Anybody that's working on debugger, I'm not horning in on your stuff. Is on the language server protocol. A language server looks a lot like a kernel process, except it's different. It's got a different life cycle. It's got different expectations about it. And you really don't want to be spinning them up and tearing them down all that time, especially, guess what, the node one, because it can take like 30 seconds to load up your diagnostics or whatever, right? Just like to be working. So I don't know, that when I switched it over from being a bespoke WebSocket to using comms, man, stuff just works, like it stops and restarts, and you don't even know the way the lab handles it. You don't even care, you just talk to it. And I think that's the level of robustness that we need, that extensions authors, core, God bless you guys, but as extension authors, they're going to need something that's simple to interact with. And I'm not sure if having to deal with the guts of a custom WebSocket are going to really make them happy. I don't know. Maybe the data store takes care of all that, and the extensions authors don't care at all. But yeah. Anyhow, so yes, please, Vito.
And I'll just want to say,
Well, I was just wondering if you had any.
Go ahead.
Oh, so sorry, Nick. I just wanted to ask you if you had any thoughts about whether such a kernel should be per server, per collaborative object, per document, or whether this should be just for the supernode, or exactly how you were envisioning this, or whether was it just kind of protocol like network?
It's protocol. I mean, I got a JEP I'm working on, and you know, for a wholly other topic. But in this case, I trust the browser as far as I can throw it. And so in an authenticated environment, I would trust my kernel way the hell more than my browser. And so I actually
No, I mean,
see it
how many of these kernels would you think you would need per session?
how many
what I'm
identities
asking.
do you have?
So
I guess that's
one per user?
I think you'd be one per user you are representing yourself as. So let's say we were on this call. I had a Jupyter Lab open. I connect to this call as Nick, the unauthorized user of a Zoom web client, and I had to hack the URL to get here and whatever, right? Like, you don't trust me. I am nobody. Maybe you can trust me by the things that I say in the notebooks that I write. But then in the same lab, I may want to be working a back channel with my people in my company. None of them are here. I'm not even working right now. So that would be two kernels. One of them would be handling my identity as this anonymous knucklehead talking to you guys, and one would be handling my identity back to my company.
Right, and then you would be able to share access. You would need to be able to share access to that kernel for the collaboration to work, right?
For the duration of that session, yeah. Now, and that's ignoring all the WebRTC stuff and everything like that. But that's another thing. WebRTC is a giant gaping security nightmare waiting to happen, and people are going to turn it off.
Right. Currently, nothing in our stack, I think, relies on WebRTC.
Yeah,
sweet. I love
right
it.
now we're using
so
Socket.io. Just wanted to clarify, for the proof of concept at least, it's just using Socket.io to deal with a lot of the WebSocket kind of stuff.
Cool. That's great. That's great. It's got a bunch of other things that we don't control, but it does work in other languages. You can use Socket.io in other languages. That's great. Anyhow, sorry, Saul, we cut you off.
No, it's all good. Yeah, I think that's also that communication is probably the least certain part of this at the moment. At least it's pretty up in the air what it actually ends up being. But I think one thing to note is, at least the way I'm seeing this wouldn't require Jupyter Lab. So requiring the Jupyter Lab like comms and kernel mechanism defeats some of the purpose here, because the hope is that it would provide these things outside of the Jupyter Lab environment as well for other front ends.
Well, but I mean, a Jupyter front, a COM is a Jupyter front end abstraction, so that is not. Yeah, I'm not. I mean, I do understand if we were trying to represent arbitrary web applications that have nothing to do with Jupyter, that's a different story. But here, I think the scope is Jupyter, and comms are a part of that. So I mean, I don't think that's the only concern, but
yeah.
But yeah.
Okay. Well, if there's, are there any other thoughts on that, or should we move on to the performance testing? All right, Brian, why don't you take it away?
Yeah, so I have been doing work on the performance of Lumino. Have a pull request open on some benchmarks. I'll continue on that. The other thing that I've started to work on is the performance characteristic of the different fields is highly dependent on how we generate the underlying IDs. These CRDT algorithms rely on totally ordered IDs to represent basically as metadata on the fields to track the history of the objects across users. so one of the things we're going to need to do to change the performance characteristics is change how we're doing ID generation. To do that in a robust way, we need a test suite. So I'm adding tests to the ID generation code paths, basically trying to get the test suite and the performance benchmarks there as a baseline, so we can look at other ID generation schemes. There's another part of performance that we have not thought about, and that the author of YJS has commented on, and you certainly see that, and that is not in the ID generation, but in basically the time to apply a transaction from a remote host. And this is really relevant when you're loading the initial state of a document. You have to basically replay all the transactions. So YJS has they've done a lot of work on a binary packing format for transactions, and we just haven't looked at it yet, but I don't think that part is tricky from an algorithmic perspective. It's more, leveraging something other than verbose JSON data structures for transactions. I think will get us most of the way there. So yeah, that's it on the performance and testing of the Lumino data store. And yeah.
If I could just add something there, in terms of the loading a document, there are ways to add checkpointing logic so that you wouldn't need to apply a full stack of history if this is a document with a lot of history. There are some ways to do it. There is a synchronization step that is needed to ensure that any people who are having network issues as you create a checkpoint are not left out, but that's a solvable problem.
Yeah, that's a really good point, Vidar. And some of where this will be interesting, and I think that these challenges are independent of any particular CRDT algorithm or implementation. Where those checkpoints are also relevant is when you double click on the file, you pull the file from disk, you have to make some attempt to validate that the state of the file on disk is actually represented in the current transaction history of that document in the data store. And so I think that type of checkpoint
right.
is really useful.
So I think that's question. I don't know if this has been discussed before. I can make another entry point for it, but just about what are the lifetime of collaborative sessions, that what is the level of these. But I can make a point about that later on.
Yeah, and that has a deep performance impact.
Sweet. Well, tests will be nice. And I'm curious that other library is going through some pretty active changes, it seems like, in their performance characteristics as well. I haven't had a chance to look at that at all deeply, but curious if you had looked at that or had any insights from it or any thoughts.
So yeah, I mean, it's fantastic to see auto merge improving. I would say, I mean, the current state of affairs. So my fundamental conclusion here is that there is no magical CRDT that has all the right characteristics, flexibility, etc. It's a pretty active area of research, and there's also not a single requirement, in the sense that some CRDT algorithms are good at certain things and bad at others. And for example, our scalar and map implementation, I think, is particularly good right now. Our list and text are decent, but not as memory efficient as they could be. And what trade-offs you make depends on your usage case. One thing that gives me a lot of sort of confidence is that our implementation is flexible enough for us to make different decisions down the road by simply swapping out how we're handling ID generation and field metadata. And that flexibility is incredible. And I don't think any other library is structured in a way that its core performance aspects are so cleanly abstracted. And so if we discover there's a particular implementation of a text CRDT that looks really attractive for large text files or for small notebook cells, great. I think we'll be able to pivot around that. So yeah, I think it's great to see a lot of people exploring these things, and I think it's still needed at this phase of development for sure. I've not actually, but more concretely, I've not run Lumino versus YJS versus the improved auto merge yet. I've not done that, so I don't have a sense of where the improved auto merge comes out. The YJS author compared it to YJS, but you really need to run it all on one machine to get a consistent baseline on that. And the other huge trade-off is between performance, speed, and memory consumption. That is, you can come up with much more sophisticated algorithms that use more complex metadata, but at the trade-off of performance of applying transactions. So it's really subtle.
Did you want to talk about the model work in JupyterLab too?
Yeah, so in JupyterLab, the document manager and document registry have this idea of a model factory, and it allows the extension author of a particular document widget to basically manage the model lifecycle that sits underneath the widget or the view. Right now, we have a sort of multi-layered model system, and at one layer we have this object called model DB, which is a very biased way of representing of modeling data in the front end. So in Vidar's earlier work, he implemented an adapter between the Lumino data store and model DB. I don't think that's going to be the ideal way of managing this. I think the model of the two data stores is pretty different, and you end up with so many different layers of model. It's really confusing to follow. The other is that we want to be able to build real-time capabilities into JupyterLab without breaking core APIs. In other words, we'd like to be able to do this in extension work that we eventually merge into master, rather than massive, huge pull requests that break lots of APIs that are long-lived. So what I've been starting to do work on is to make the usage of model DB more optional, and to allow model factories to basically choose what data modeling system they would like to use. So maybe someone's building a front end and wants to use just talk directly to a GraphQL server, or someone wants to use Redux as their front end data model. It should be really easy for the model factory to provide models according to that, rather than using model DB. I think it's actually a teeny amount of work, and we'll be able to do this for 3.0 without, I'm hoping without breaking any APIs, just additively. I'm not proposing that we, for 3.0, get rid of ModelDB, more just that we make it optional for extension authors. So basically trying to make the RTC work easier to do in a more loosely coupled way.
I have a question to that. Ian also did some work to switch to using the data store. And I guess Saul was also quite involved in that. But as far as I understand it, if you're saying who should create the kind of, you're saying that an extension should be able to choose to use a different backend. But the other kind of use case you would have is that, hey, I'm an admin and I'm deploying this for our system, and we want all different extension systems to preferably use this kind of model because that's what suits our plant. Are those two compatible in what would be kind of be the intermeshing of those two cases or concern?
I don't think they're compatible in the sense that there are extension authors that are building extensions using already, but in a hacky way, their favorite data modeling system. And I don't think there's any way or any way for all extension authors, so for example, maybe your document is backed by a GraphQL endpoint. I don't see any way we can sort of reasonably expect extension authors or admins, for that matter, to say, I want this extension to not be deployed on the GraphQL backend. I'm
right, but so what I'm trying to ask is, so say we have the RTC system and somebody writes an extension that uses this GraphQL thing backend instead.
Mm-hmm.
If they wanted RTC, then they would have to build their own RTC system on top of that backend.
Yeah, and absolutely some of what I'm observing is that different extensions have different need to support different user stories and use cases, and for some of them, real-time collaboration is not relevant, and they can use GraphQL, and there may be other reasons that they want to use GraphQL. Where the big shift here, so right now, actually, it's deep down in the services and the content service specifically that the model DB is generated. And the reason that is that in the earlier Google Drive implementations, the sort of Google Drive was treated as a Jupyter Lab drive, and every model coming out of that needed to have the same type of model DB generated for it. I think I'm not proposing we get rid of that code path, but that we allow extensions if they want to say, I don't need that one. I in all deployments, my extension needs to use this type of data store rather than one that's provided by Jupyter Lab services. Longer term, we could think about, okay, should ModelDB itself be replaced by the data store as sort of a default available thing? But I think that would be a longer term project.
Okay, but then so if I just understand you correctly, you're saying that so if you have a separate data format, a separate data extension, some other, like a movie or so some data cube that you want to manipulate, and you make an extension for interacting with that. And what we're saying is that if you have two different extensions that can both act as viewers or editors of that, how will they will not be able to cooperate on that. They would just need to use their different data stores to represent the same content side by side.
Not necessarily. So this is one of the questions that I think is important. So the document manager caches these context objects that hold on, and the context object is templated over the underlying type of the model. Like some of this is already actually in place. I'm hoping we could still have multiple independent front-end extensions with different views, rely on the same underlying data model that's chosen and provided by that author. And what's a little weird here is we already have a multi-layer approach here where there's the ModelDB layer, and then above that, there's the actual model layer, and the context object is templated over that higher level model layer.
Right, I see. So you're saying you should share on the model layer, and then whoever implements that model gets to decide what the underlying.
That's my current thought about the sort of path of least breaking lots of things. But it's there's a lot of complexity here. So, you know, I'm going to put together a pull request to Jupyter Lab, and then we can discuss and see if it makes sense.
And Vidar, I guess you added some questions here about session lifetime stuff.
Yeah, about session lifetime and session level. So there has been some discussion. I think we discussed this a little bit on an issue of the question of how much data should one session encompass? Should it be like the full UI state, or should it be per document or some other kind of logical level? And the other question is, what kind of lifetime do we expect those kind of sessions to have? And for me, the reason I want to ask this question is that they kind of intermesh closely with some of the other kind of use cases you would want to have, and what kind of user experience you could create on top of the RTC. So for example, if you have only that the session lives per user session, modeling the full UI state, if that's the default thing, then the question is, can I share a part of this session with somebody else? So for example, can I share a specific notebook with somebody else without them gaining access to all the other stuff I have in my session? So that's probably possible, but the question is just how much work would that be? And of course, if you say we should put the collaboration or the session per collaborative session on a per document thing, then you could consider yourself, you can have a non-RTC session normally, and then you could say that now I enable RTC for a specific case. So I know that we're talking about like replacing the full kind of in-memory model that we have currently with just RTC. And for me, that's, if we do that, then any performance issues with the CRDT algorithm becomes enormously critical.
Yeah,
if we have the full UI state backed by CRDT for the entire lifetime of everything, then the performance is, you know, everything, alpha and omega. If you say that this is something I turn on for an hour so I can share this document with a class or with a friend, then if at the end that state is starting to come a bit sluggish or large, that's not as much of an issue.
Yeah, Vidar, I think these are super important questions. My sense is that it makes sense to start with a more transient RTC session, and the life cycle I've been thinking of is if no one has the document open currently, then we reset the state. when someone
Right,
opens it,
but so you're saying if you're working on your own, you create a new RTC section still.
well, I mean, from the perspective of it's still using the same data store.
Right, and then you get the super node.
Yes, I mean, there's
so every but would that be on a document basis then, or would that be? So maybe another question is, Saul, for the super node, is there any? Does it have to live on a per document basis or per session basis, or can it be work with either case, for example?
Well, the way I've been thinking about it is just global for all users, all sessions, all documents. We have one data store. And there are performance and permission questions there. I agree, but I was hoping maybe we could tackle those.
And also, I'm less worried about there being a large number of tables and a large number of records in those tables. I'm more worried about maintaining long histories for particular fields and particular records. That's where the performance is going to be really. Yeah, I mean, I don't even know if there's any CRDT on the planet that we could reasonably expect to be able to. For example, I install Jupyter Lab on my laptop. I start working, in 3 years from now, all I've done is add to that history. I don't think there's a CRDT on the planet that can do that.
Yeah. So it seems like the checkpointing or collapsing transactions kind of flow could help with that.
Or even just blasting. There is synchronization questions here, but the simplest thing to do is, after some period of time of no one having a particular document open, you blast the history of that document from the data store tables, and you reload that state next time someone opens a document.
Yeah, it's probably just, I'm just thinking it's more complicated probably to look through the history for a particular model. Like, what if it's a transaction with multiple documents and one? I'm just thinking the simplest would just be, hey, take all history after 10 minutes or half an hour and collapse it to one transaction or something like that.
Right, so you would need to do some synchronization to ensure that nobody has been disconnected for that period of time. Or that at least you keep a certain amount of, you need to keep the history from the last transaction all collaborators had.
Yeah.
Yeah.
Depends how long you want to let people work offline before coming back online, I guess.
Yes, and I'm saying that the smaller the amount of things that can be worked on is, the easier it is to avoid debilitating problems about that. That doesn't mean we shouldn't try to necessarily tackle the big one. I would argue for starting smaller and then scaling it up as needed, but that might be just me being overly cautious. I don't know.
No, I totally agree. And I think the core algorithms of CRDT are going to quickly fade into the background as we tackle these problems. I think these questions are going to be independent of which CRDT algorithm we've implemented, or if we were to use some other library. It's all this stuff that's going to be the actual hard part. And where we need a high degree of customizability because we're making all these decisions and trade-offs and so on.
And I think the permissioning thing is even more complicated if we do end up with like a role-based permissioning or very granular permissioning. I'm not sure at all how that will work with this system and how you verify, hey, I changed this document. Am I allowed to change this document? Who verifies that? Does that have to be in the relay server? those kinds
Right.
of
Another way. Oh, sorry. Go ahead. Oh, no, I said another way to organize this would have one session that is like the UI session or the full UX session that only tracks stuff down to the which documents are open, and there it just links to another RTC session that is a specific RTC session for that document. So you would have one session per document
that are different, right? Like you might say,
I'm sorry.
Hey, you can edit. You might say, hey, you can execute this cell and can't execute that cell, or you can edit this cell but can't edit that cell. Or I guess my concern is that the permissions are going to be possibly so, we might want them so granular that it might not help to break up split the tables into who has permissions to work on different things.
Right. Now I wasn't thinking about the permissions issues. Now I was thinking about more like lifetime and syncing issues. But that's also a good point. So what I was thinking is if you have one RTC session per document, because normally documents are the stuff that gets edited most heavily, right? Then you have a higher number of points where you can kind of collapse the state or reset the state as needed. And then you could have one RTC session that is tied to the global UI state, for example. That would then just have the lifetime of whatever the browser tab that is open or whatever. Or I guess that user session. And that could be collapsed whenever the page is refreshed or something like that. I don't know. So if you're saying that it's something we want to have be able to share fully the complete UX state or the UI state, then that's a possible way to organize it that lets you have both. I'm not sure what the consequences of such a thing would be technically also.
But so a bigger comment on permissions. Jupyter allows arbitrary code execution in the front end and back end. And so if someone can do that, finer grained permissions are pretty meaningless. That's not to say we can't do some notion of permissions, but if a user can run any code, they can run all code and they can do all things. And so
yeah, if it can run any code, but sorry, go ahead.
Well, I would just say, what if the kernel's in a container? You have a remote kernel or something in a container, and you might not be able to access. Just because you can run something in the kernel doesn't necessarily mean you could change documents, right? Or mess with your host system, or.
But I don't think we can make assumptions about how Jupyter is deployed.
So another example is that I would say that the permissioning would happen on the server REST APIs.
Yes. Yeah. Exactly. And that's what.
And that's where we would have cell execution. I'm saying is the RTC should also have some permissioning on that level, saying like, can I connect to this session, this collaborative session? Can I read a state from this? Can I write state to this collaborative session?
Yes. Yep. And that's the level of permissioning that Zach's been working on in the Jupyter server. And yeah.
And what would also be interesting is we have a super node that I'm not sure how it's currently being implemented. So please answer afterwards. But there was a discussion previously about having the supernode being responsible for handling the execute requests to the server. And at that point, the permissioning kind of gets a little broken bit. And also, if that supernode is writing state to the notebook document model, then that basically means that everybody who has permission to write to the RTC session also gets permission to write to the notebook state, or that it's not possible to hide something.
Yeah, I think there's a bunch of different permission questions: how to hide, how to stop edits, And then also you had to stop you from allowing to do actions on the server. And probably all have to be handled separately. I mean, I had, like, one thought is, if you're doing an edit, maybe when you send a transaction, you could have a user ID, and it could verify that, you know, somehow the transaction is linked to your user ID or something like that. So when the RTC supernode looks at it, it says, oh, this user said execute this cell, and they're allowed or they're not allowed to do that thing.
Right, but so does the supernode currently is the supernode currently responsible for executing, or is it only responsible for processing outputs?
It's currently responsible for executing.
Right. So then one possibility, if we go with that pattern, would be to kind of pass through whatever authorization
through
things that are coming in with that request.
Yeah, exactly.
I've got to jump.
Oh, wow. Look at the clock. Yeah, good point.
All right. Well, thanks, everyone. I'll see you in 2 weeks. Take care.
Thank you. Bye.
Thanks.
Thank you.